Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE maths? Well, if you are, please continue to watch, as in this session, we look to tackle the topic of basic geometric proof, and I suppose actually, more accurately, basic geometric reasoning. Now, we'll always be calling upon your prior knowledge and previous understanding, and this session is no different. For example, we will be requesting or demanding that you understand the angles in a triangle add up to 180 degrees, for example, or corresponding angles are equal, alternate angles are equal, or the angles on a straight line add up to 180. But as always, if we do touch upon any topics that you're not sure about, please check out our other videos. But for now, if you are looking to achieve one of the highest grades possible in GCSE maths, please continue to watch. So in question 1, the exterior angle. So an exterior angle would be this one here, of a triangle is 118 degrees. One of the opposite interior angles is 47 degrees. Find the remaining interior angle. So it's labelled X. Well, hopefully, without too much hesitation, people will realise that this angle has to be 62 degrees. If I just underline it, and I will colour code the notes for clarity, so if I do it in blue, we know that this interior angle has to be 62 because the angles on a straight line have to add up to 180. And 180 subtract 118 degrees equals 62 degrees. Now, we are left to find X, but here we have a triangle. And what must the angles in a triangle add up to? 180. So we have 47 add 62, and that equals 109 degrees. So to work out angle X, we do 180 subtract 109 degrees, which equals 71 degrees. Now, as always, these questions do start at a relatively low level, and then they will build up in their difficulty gradually. But remember, this is a basic introduction to that geometric reasoning. So if I scroll down, question 2. Angles on parallel lines are labelled 2x plus 10 and 5x minus 50. They are corresponding angles. Find X. Well, the first thing I'm going to do is just use a coloured pen to demonstrate the fact that these angles are corresponding. Now, corresponding angles have I suppose it's a nickname of being called F angles. And if you can see here, these blue lines create an upside down F. It doesn't have to look like a traditional letter F in the alphabet. They can be at any orientation. And here you can see we've got an upside down, slightly on an angle, F angle, or properly named corresponding angles. And corresponding angles are equal. And that's the key concept here. So straight away, we can say that 2x plus 10 must equal 5x minus 50. And what I'm left with here is an equation to solve. And for those of you that have seen any of my other videos, when it comes to solving equations, you will know I like to include a mini margin, just for that clarity and to keep my notes organised. The first thing I will do, the inverse of 2x, is to subtract 2x. And remember, we must balance our equation. So that will leave me with 10 equals 3x minus 50. Well, the inverse of minus 50 would be to add 50. So that would give me 60 equals 3x. To remove the coefficient of x, in other words, what's the inverse of times 3? It's to divide 3. So we get 20 equals x. Now that is answering the question, but let's just try and add that clarity. If x is 20, 2x would be 40, add 10 is 50. And let's just double check. 5 times 20 is 100, subtract 50 is 50. So both of these angles are corresponding, they're equal. We've calculated x to be 20, but moreover, we've actually worked out each angle to be 50 degrees. And with that in mind, I will just add in my units. Question 3. In this question, we're calling upon your prior knowledge of circle theorems. Now in circle theorems, when we have a cyclic quadrilateral, what that means is we have a quadrilateral inscribed inside a circle whereby each corner of the quadrilateral lies on the circumference. So that's the definition of a cyclic quadrilateral. Each corner must touch the circumference. And when it comes to cyclic quadrilaterals, one of the circle theorems is that opposite angles have to add up to 180. So straight away, let's write that down. 3x plus 15 plus 2x plus 40 equals 180. And I can now simplify things by collecting like terms. So that will give me 5x plus 55 equals 180. So now we're being left, or asked rather, to solve an equation. Straight away, to add that clarity, to build the confidence, I draw my mini margin. And the first thing I'm going to do the inverse of is plus 55. Once again, we must remember to balance our equation. So 5x, subtract the 55 off 180, will give me 125. If I then divide by 5, x equals 25 degrees. And again, we can now check. 2 times 25 is 50, add 40 is 90. 3 times 25 is 75, add 15 is also 90. 90 add 90 being 180. Please don't assume they're always both going to be 90. That is by pure chance. And you can see here the diagram is only a sketch because quite clearly this angle here is slightly less than 90 and this angle here is slightly more than 90, but it is only a sketch. It's not drawn accurately. It's not to scale. Question 4. In triangle ABC, angle A is x, angle B is 2x. An exterior angle at C measures 5x minus 18. Find the value of x. Okay. Well, the first thing I notice is this. The angles in a triangle have to add up to 180. So what we can say is if I label this angle here, I will label it M. Straight away we can say x plus 2x plus M equals 180. Therefore, 3x plus M equals 180, which implies M equals 180 minus 3x. So I've just written that in blue. However, If I was to go over this and write it in red as well, I'll still call it M. The angles on a straight line must also add up to 180. So in other words, M plus 5x minus 18 equals 180. So M equals, by balance, minus 18 to the side, 198. 198 minus 5x. So we now have two expressions for M, and M is the same angle. So these two expressions, 198 minus 5x, must equal 180 subtract 3x. Once again, we have formed an equation. I'm just on my taskbar here. Because I've formed an equation, I like my mini margin to add that clarity. The first thing I'm going to do is do the inverse of subtract 5x, which is add 5x. You can do these operations in any order. I just like to avoid negatives if I can. So that would give me 198 equals 180 add 2x. I can now subtract 180. That will give me 18 equals 2x. And if I divide by 2, I get 9 equals x. So this angle here would be 9 degrees. This angle here would be 18 degrees. This angle here, 5 times 9 is 45. 45 subtract 18 gives me 27 degrees. So this angle here, let's just double check. 18 add 9 equals 27. Well, straight away, the exterior angle at C is 27. The two angles in the triangle add up to 27. Therefore, angle M would be 180, subtract 27, and that equals 153 degrees. So this angle here, I know we're not being asked to calculate it, but I'm just increasing the clarity, would be 153 degrees. Remember, if we've touched upon any topics that you need further support with, please watch some of our other videos. But for now, thank you for watching and good luck in your quest as you aim to achieve one of the highest grades possible in GCSE maths. Thank you very much.